Life expectancy, what about it? No, raise your hands, I hear some people, I'm actually gonna pause it. So, at the end of the day, if this question comes up on the AP exam, what is the main reason for population increase in the world? It is because of decline in death rates. It's not about the increase in birth rates, because now we're gonna start to monitor graphs, and you're gonna see that birth rates have declined everywhere. Well, I already showed you that yesterday. In the world, we saw a drop almost by half in some areas. They're still high in some areas, but they've declined. Death rates decline is the reason. Life expectancy changes. And here's just some graphs on life expectancy, and you see across the world, I mean, people are living, in the United States, what's our life expectancy? 77. And this is 2006. I really need to update this. A survivorship curve, it's exactly what it says. It shows the percent of a population that is likely to survive at a given age. So let's try to interpret this graph so we can make sense of it, because you could get this graph and it could be titled and you have to understand. Let's start with humans. Migration effects. What will improve for the economy? I don't even know what it says there. Oh. Obviously, the economy will improve. And I guess this is why people migrate, okay? Political freedom, because that's obvious. People want to leave. Religious freedom. Wars and environmental refuge. Jeez, which means what? Environmental conditions can definitely affect migration, like a massive earthquake. We saw that. People migrated to the United States, right? Even to the school. And what she was trying to reference was if there's a condition like massive pollution in a given area, people leave. I mean, for health reasons. So yes, that's definitely a contributing factor. Going to show up on the AP exam.
And on the test?
And on the test, of course. So this is called an age. In the past, I've had students draw this diagram. It was a classwork grade, because you would look at my notes and you wouldn't have copies. I need you to understand that you will be dissecting this whole diagram piece by piece, and you have to understand it. So if it takes drawing it to understand it, please do so. This is basically a way that we can calculate distributions of ages in a specific population at a certain time. Okay. In the end, if you look at both, all four of these graphs, you can kind of reference that this is less developed countries, and over here we've got more developed countries, okay? There's gonna have, it doesn't matter what you reference, what area of the world, you're always gonna have males on one side and females on the other. The red represents pre-reproductive ages, which is 0 to 14. The yellow is 15 to 44, or I should say the middle, because it's not going to be color-coded on your test. And the top is post-reproductive, which is 45 to 85. Why do they put plus? Depending on the life expectancy or the age. Do you think these age levels can change? Yeah, because reproductive ages between 15 to 44 sounds pretty correct for today. I'm sure 15 years ago or 20 years ago, it was 15 to 30, because anybody that was having children at 35 were really considered post-reproductive. Now, people are having babies at a later age, so 44 is still pretty high.
I think it's going to stop again. I think
some countries have a lot of their population between the ages of 0 to 14. We call this rapid growth. That means they're going to lead to a rapid growing population because they have the majority of their population is either in reproductive years or pre-reproductive years. And examples, they also call it expanding rapidly. You're going to see different names, but you know it's going to grow fast. Then you've got this next one. What does the growth look like? Moderate. They call it slow growth, and expanding slowly is another way to describe it. United States is there. We have kind of like, almost like an average pyramid, except it's thicker in the bottom. So what about the next one? Zero. It's actually zero growth. And, or stable. They have those words as well. And the last one's negative.
More middle-aged to like older people.
Again, at different factors between 1900s and 2000 of things that have changed. So life expectancy change. Remember the graph I gave you was only like in the last, I think from 2006 to 2000, I don't remember. But look at the difference in 47 years ago and 77 years. I mean, 1900s to 2000. It went from 47 years in the 1900s was the life expectancy to 77. And we know that we're at some places like 80. Married women working. Check that one out. 8% to 81. I'm sure we're at about 100 or at least 93. High school graduates, 15 to 83.
Wow.
Homes with flushable toilets.
Okay.
Well, hold on.
Well, let's analyze that. Why is that such a key factor? Sanitation. I mean, huge. Homes with electricity, 2% to 99. I don't, 1% without? That's living in the suburbs, 10%, well, whatever. You see all these things that came into play. This is going to sum it all up for you. This is called the demographic transition model, and it's basically a hypothesis to describe population change, okay? And we learned this in the first unit somewhat. It's all based on the industrial society because the industrial society is the reason, the main reason for the exponential growth of the world population. But if you look at what they call pre-industrial, and you can look here or here, these two things are identical. One describes the graph in words, and the other one is the actual graph that you need to describe. So it can work both ways on the test. So pre-industrial, and I'll jump back and forth. Birth rates and death rates are both high. So obviously your population is going to either be stable or slow and steady. And this we could kind of reference as our hunter-gatherers. Remember that? Their birth rates were high, their death rates were high. They never stay in one place. Their kids, there's a lot of infant mortality rate, and their life expectancy was low. So this is what it looks like on the graph. I may not have to tell you this bottom, where it says crude birth rate, crude death rate, and total population. They may not label that for you. Because you, by knowing the facts that birth and death rates were both high, you can reference that that's the pre-industrial, and you could reference that the black line is population change, because it was steady. Does that make sense? Okay. So we move on to stage 2, which is agricultural, good, and we improved food supplies, we settled down, we started to take a shower, we brushed our teeth, so there was less disease. So death rates began to decline. What happened to birth rates? They're still high. So what's going to happen to the population? It's going to go up. Look at the graph. Birth rates are the blue. They stayed high. Death rates dropped like significantly. So you know that in the second stage, you see that drop in the graph. You know that line represents death rates. You see the increase in the graph. What do you start to see there in transitional? You start to see what? Total population doing what? Spiking. What do we call that? Exponential. I see the J starting. Yes? J-shaped curve. Okay. So we go to industrial, which is everything changes. Women become educated. We have contraception. We have social factors, that lead to less birth rates at an earlier age. So birth rates begin to decline, and death rates decline even further, and the population booms. Look at the graph. Death rates drop again. Just a small window here. We're starting to see something change here. Birth rates dropped significantly, and the population continues to grow. Post-industrial, which is, remember when we did future societies? And I made you create a society that you believed might take place, and you had to mention energies, and population was on there. And they actually believe that the population is going to stabilize. So if you look at the graph, what do you actually see happening? Interpret the graph for me.
The death rate is going to be.
The death rate what?
The death rate and the birth rate are.
Nope, look at it. Interpret the graph. The population becomes constant. That's this line, right here. What else? What's happening to death rates? I don't see stabilizing.
Increasing.
They're increasing. Look at the red graph. This is what I say about interpreting graphs. You don't guess what's going to happen. You look at the graph and you interpret it. In this graph, death rates are increasing. Why? Let's answer.